Hello students, welcome to Akshara 8 Foundation. So in the last class we have completed the concept of Newton's laws of motion. Then all the concept synopsis we have completed there. Today we will do there one by one, concept wise, synopsis wise, we will do the numericals. Okay, in the first synopsis there are all the, it is about the Newton first law based on the inertia. Okay, so about the inertia, types of inertia, there are the questions will be there. So that you will see here first question in concept based questions. First one you see here. So synopsis one. First question it is given here. Inertia of a body is directly depends on it. Okay, depends on what? So we have discussed it there in the last class. Mass is the measure of inertia. Okay, inertia can be measured by the mass there. If mass is greater, inertia will be greater. Mass is lesser, inertia will be lesser there. Okay. So then it will be depend on mass of a body there. So the first answer is mass. And the second one you see here. Behavior of a body under zero resultant force is given by. Okay. So behavior of a body under zero resultant force is given by Newton's second law. So resultant force is force equation. Okay. So if a resultant force is zero, then the acceleration of the body will be remains. It is zero, no. So it is based on the first equation of motion. Sum of all the forces is equal to zero. Net force is zero means then. So it is the Newton's first law. That is depend on the Newton first law. Newton's first law. Which law is demonstrate that? Okay, that is the Newton's first law. There, sum of all the vector sum of all the forces will be zero. Then the body will be remain in its state there. Okay. So if it is not equal to zero, then the body will be accelerated. So it is Newton's first law. So Newton's first law is the answer. Third option is correct. And which are the following? Which law of Newton defines an inertial frame of reference? Which law of Newton's define inertial frame of reference there? Okay. So we can write here inertial frame of reference. So that is also Newton first law of motion, inertial frame of reference. So we said that inertial frame of reference is nothing but the frame of reference in which the Newton laws can be applicable. So that is, then we can write here the force. The sum of the other forces will be zero, no? So it is Newton first law of motion. And then next one is given here. You are thrown outer side when a car is suddenly take a turn there. Okay. So while we are traveling in the car or in the vehicle or in the bus, okay, if the vehicle is taking the left turn, then the passengers we will be thrown outwards. That is because of the inertia of direction there. Okay. So when the body is taking the direction it changes, then the body it does not changes its direction. It want to be in the same direction. So because of that reason, it will be thrown outward. Okay. So that is due to the inertia of. So they are asking there which law. So that is the first law. Okay, first law. And in the first law, what is the type of inertia there? It will be act there. That is the inertia of direction. So like about the here, all the questions are based on that inertia only. Examples we have discussed the examples of inertia. Based on that it is there. The next JEE mains questions you will see there exercise problems. So all are theoretical questions. So these are all the problems you can do there. Okay. So we'll see there a few of the questions. Then later we'll go to the next synopsis there. So your first one is given here. Newton's law of motion describes the following. So it is explains about the inertia and the force now. So here it is force is not given. So inertia is given. Then it is the inertia of inertia. So first law will be explains about the inertia there. When the branch of a tree is shaken, the fruits fall due to. So when the branch of a tree is shaken there, all the fruits will be fall and dried leaves will be fall there because of the inertia of rest there. All the fruits will be at the rest there. If suddenly the tree trunk has shaken, the branch has shaken there. So then the body is getting into the motion, but the fruits and leaves will be they want to be tries to be at the rest only. Okay. So because of that reason, they will be fall on the ground there. That is due to the inertia of rest. A rider on back horse falls back when starts running suddenly. Okay. So when the rider, so he will be fall back when it is suddenly starts running there. Okay. That is due to the inertia. The rider will be at rest there. Suddenly it has started there. The body is coming into the motion, but the rider will be at rest there. He tries to be at rest only, but there is a motion happened there. Then so immediately it will not coming into the motion. He will be fall back. Then by holding that threads and ropes, he will be come again onto the. So he will be set right on the horse there. Okay. That is due to the inertia of rest only. So like this example which I have discussed, based on that only all the questions will be there here. See here, back side it is given there. Inertia is the property of a body by virtue of which the body is so unable to change its position or state or uniform motion by itself. Unable to change here, they are given there. Uniform motion is given, unable to change itself direction. So unable to change by itself state of rest and uniform motion. Okay. So this all will become there. So in the last one, the fourth one, everything is given there, so that we can take there. Inertia is nothing but unable. It's a state of rest and uniform motion. That is the okay, like that. Based on the inertia only, these all the questions will be there. Next here you see there 10th question. There are two similar spheres such that one is made up of lead and other from the wood, which will have the more inertia. So which will have more inertia there? So according to the first law, it is mass. Inertia will be measured by its mass there. Which one has the more mass? That will be has the greater inertia. So lead compared to the wood, lead will be have the greater inertia. So the greater mass. So the that will be have the greater inertia there. Okay. So like that, based on inertia only, these all the problems will be there. So if you have any doubts from this, you can ask there. Then in the doubt session we will be discuss. Okay. And now next one will be synopsis 2. The synopsis 2 you will see that. The synopsis 2. So in synopsis 2 explains about the Newton's second law of motion and linear momentum. Then law of conservation of linear momentum we are going to see there. Okay. So change in momentum we are going to discuss. Then we'll see here the concept based questions. Which of the following is most significant law of motion is given by Newton? Okay. So which of the following most significance? So the significant law is, it is measurement of the force is given, that is the second law. So definition of the force is explained and expression is given. Okay, SI unit and dimensional formula, everything is given by this. So that is the significant law, that is second law of Newton's. Then a car accelerates on a horizontal load due to the force exerted by the okay, car accelerates on the horizontal load due to the force exerted by the car on the earth. Okay. So engine on the car, road on the car there, driver on the car there. Okay. So we can say here force exerted by the, even if the engine is on there, it cannot be moved there. If the car applies the force on the earth, then only it will be moved forward there. Okay. Even while we are walking. Okay. So to walk there, we should apply the force on the earth in backward direction, so that we will be moved forward. Okay. That is because of the inertia, because of the what we can say there, frictional force, then we can walk forward. The proportion of rocket is based on the principle of conservation of linear momentum. Okay, this we have discussed there. Change in momentum per unit time is represents change in momentum. Change in momentum. Here in the second law we have discussed, also discussed the impulse there. The change in momentum is nothing but the impulse, no? So it is the impulse is also defined as the product of force and the time. Okay. Impulse is nothing but a large force applied for a short duration of time on the body, then it is said to be the impulsive force, or it is called impulse there. Okay, that is also it is equal to the change in momentum. Okay, based on that only you can do this all the conceptual bits. If you have any doubt, then we'll discuss later. Then next exercise problems you will see there, single correct answer type questions. So first question you see there. Okay, in that first question, a body of mass 25 kg has a momentum 125 meter per second. What is its velocity? Okay, so mass is given here. The mass of a body is first question. So mass of the body is 25 kgs is given there, and it has a momentum. Momentum is given here 125 kg meter per second is given there. And what is its velocity? They are asking there. What is its velocity there? Okay, so V they are asking there. So what can we use the formula here? Linear momentum nothing but mass into velocity. Mass into velocity, no? So from this velocity we should find out here. So it is P by M we can write there. P, how much it is given there? 125 divided by mass is 25. 25 1 and here 5 is. So therefore how much you get there? So V is equals to 5 meter per second. It is a 5 meter per second. It is a 5 meter per second there, okay. So based on that only here next one also that same formula. Change in momentum we are asking there, okay. This one will see there. Third one will see. Second one is homework you can do. So third one we'll see here. So here it is given there mass, a car of mass 200 kg, okay. And it is moving with the speed 20 meter per second. It is moving with the speed of 20 meter per second. So means that is a moving means initial velocity. After 25 seconds, there, so it attains the velocity, it gets the velocity 10 meter per second. Means here 20 to 10 meter, it is decreased, means the body is moving with deceleration, okay. So then what they are asking there? Change in momentum. What is the change in momentum? Okay, change in momentum, that is nothing but delta, is nothing but here. Okay, so we know that change in momentum, no. So we can write here. So from the same, we can write here F into T is equals to delta P. We can write no change in momentum. So delta P is equals to, we can write here delta T also, no problem. That is equals to F into delta T, F into delta T. So then here F is nothing but what there? M into A we can write now. M into A into delta T we can write there, delta T. Or we can write T also, no problem. Even we can write T also. Then what is this? We can write here mass M into V. This is nothing but what there? V minus U by T, no? V minus U by T here into T. So how much you get it here? This is a T and T will be cancelled here. So we'll get there MV minus MU. MV minus MU. So M is how much is given there? See, and velocity how much it is? And this is a 200 and initial velocity is given there 20 here, okay. So how much you get here? This is a 2000 and this one will be the 4000. How much you get it there now? Minus 2000 meter per kg meter per second, kg meter per second, okay. So this is a change in momentum. So I let guys. This is the answer. Minus indicates it will be shows the direction there. Only the magnitude we have to consider there. That is the answer there. So answer is fourth one. A player caught a cricket ball of mass 150 grams, so moving with a speed of catching process is completed in 0.1 second. Then exerted, they are asking there force exerted by the ball on the hand of a player there, okay. So that we'll find out the next one. So here it is. One. So ball of mass is given here. One gram is equals to 1 by 1000. 1 by 1000 is nothing but 10 to the power of minus 3 we can add there. If it is a 10 to the power of minus, we can add there. So now what they have given next? They have given here speed. It is moving with a speed there. So initial velocity is given, that is 20 meter per second, and the catching process completed. So catching process completed. How much time it has taken there? So time has at 1 second, 0.1 second time has taken. Then they are asking there what is the force exerted. So force is nothing but what is the formula there? F is equals to mv minus m2 divided by time. So what happens here? The force. So final velocity. Here initial velocity is there. After catching the ball, then final velocity will become 0. So here final velocity V we can write here 0 meter per second. Okay, then here this is 0.150 into 0 will write here minus 0.150 into U is nothing but how much there 20. So divided by here time. Time here we can write there 0.1. So we can write here minus, okay, 0.15 into 20 divided by here 0.1 means, so what can I write here? 10 will be multiplied here. It will be 1.5 into 2 means 3 will be there. Again here 0.1 is there. 0.1 is nothing but 1 by 10. 1 by 10 will be multiplies here the numerator. So then get here 30 newtons. 30 newtons. Minus will be indicates it is a vector quantity. Minus indicates the direction there. Means the force which is applied by the person, it is applying the force to stop the ball there. Okay. So that represents there against to the speed of the body there, against to the acceleration, or to retarding speed, retarding a force. There is a minus 30 newtons is the right answer. A force exerted by the ball on the hand is 30 Newton per second. Okay, because the body here the speed is decreasing deceleration. It is moving with the deceleration, so force will get the negative force will get it. So based on this formula only, all the problems are there. You can do now all the problems. If you don't get, you will see there in the working session. So 10th one we'll see here now. A vehicle having a mass of 1000 kg is moving with uniform velocity 20 meter per second. Sand is dropped into it at the rate of 5 kg per minute. Find the force needed to keep the vehicle moving with uniform velocity. Okay, this one will see there with uniform velocity. So here in a truck there is a sand is taking moving with uniform velocity, 20 meter per second. So uniform velocity means constant velocity. Acceleration will be 0 here. You can consider. Then sand is dropped into it at the rate of. So while it is moving there, 5 kg meter per second, 5 kg per minute. Per minute, 5 kg mass is adding in the truck there. Okay. Then find the force needed to keep. So it has to be move with the same speed there. Even the mass is placing there. If the mass is placing while the body is moving there, certain mass is placed there, speed will be decreases due to the weight of the mass which you are providing into the truck there. So then here, so to avoid that decrease in speed there, so it has to be continuing the same speed means, then we need to apply extra force, okay, on the truck there. Okay. So then how much force, extra force needed to apply to move the body with the same speed, they are asking there. So right here 10th one. So mass of the vehicle is given here 1000, and next one is here uniform velocity 20 meter per second. Uniform velocity 20 meter per second there. Uniform velocity is given here V, that is a 20 meter per second, and mass loading. So mass loading, how much it is given there? Mass loading in the truck, it is given there. So mass per minute, mass per time, it is given there 5 kg. So 5 kg per minute, 5 kg per minute. So how much in a minute? We should convert, all the units should be in the SI system. So then time should be in the SI system, means that has to be converted into seconds there. 60 seconds, no, it is 60 seconds there. Okay. So m by t we got there. Now force, how much we need to apply. So on the truck there, that is, we know the formula here from the second law of Newton, that is m into v by here. Then m into here acceleration is nothing but v by t, no. So here a is equals to, we can add there v by t. A is equals to v by t, we have to take there. Now the force. So here the extra mass is added there. Extra mass is added means extra force we need to apply there. So that extra force, what they are asking, that only they are asking there. Extra force how much we need to apply so that it has to be go with the same speed there. Okay. So here they have given their m by t value. M by t value, how much they given there? M by t into here v. So m by t value, how much it is given there? This is a 5 by 60. 5 by 60 into how much this one? It is a u, or that you can write here. This is a v, or u. Here 20 we can write there. This and this will be cancelled. This one and here 3 is a will be there. So 5 by 3. 5 by 3 newtons. So therefore, the force needed to apply on the truck it is 5 by 3 newtons. That is the answer. Okay. See, based on this formula only, it is given there all the problems. Okay, this problem is the 11th problem. A body of mass 8 kg is moved by a force F is equal to 3x newtons, where x is the distance covered. Initial position is 2 and final position is 10 meters. If the final body, if the initially the body is at rest, find the final speed. If the body is at rest initially, then what is the final speed they are asking them. So how to find it there? We will try to solve it. Now 11th question. 11th one. So a body of mass here 8 kg is given there. Body of mass 8 kg. Mass of the body is 8 kg. And then next and force is given there. Force equation 3 into x newtons. Okay, F is equal to 3x is given there. X is the distance covered there. So their distances are given here. X1 is equals to 2 meters and x2 is equals to 10 meters. X2 is equals to 10 meters. It is given there. During this interval of distance, during that distance there, then how much speed. So final velocity is what? What is the final velocity? Then we need to find out there. Okay. So we can write like this. No, here. So F is equals to what can we write there now? So dP by dt we can write, no, dP by dt. dP by dt we can write here. Then so now from this dP is equals to F into dt we can write here. Okay. So this is a differential for shortest duration of time. Then the force is applied there. Then the changing momentum will be takes place there. The smaller force. Then we should integrate on both sides. We will get the total speed. And from here this is a dt. And here this is what is given there. 2 to 10 meters is given there. Limits 2 to 10 meters it is moving there. So integral of dP. So from this formula we have learned integration, or in the next class we are going to learn. Then otherwise here dx. Understand here dy mother in the integrations. Integration is a mathematical concept. So based on that concept we will take it here. So now this p we got, no, this is a p, and here integral of 2 to 10, 2 to 10. Here f is what is the equation is given there, 3 into x into dt, 3 into x into dt. Okay, but here we have got here this is in the time it is given there, but here it is given there in the distance, no. So in terms of velocity, we can write now x is equals to v by t. We can write like that. Distance, or so here x is equals to this one. X is equals to 3x. And dt is given, no? Time, distance is equals to velocity into time, we can write there. Okay. So now here if you do here dx v into dt. So dx is equals to v into dt we can write here now. So this we should convert into the x. They're asking here in the question, they're asking only the initial, if the initially the body is at rest there. So initially the body is at rest means initial velocity will become 0. Initial velocity will become 0. So they're asking here only the change in velocity, dp only they're asking there. So then no need to take this integration part. Okay, we can take it out. No need to take this integration part. So they're asking only the change in momentum. No, change in momentum they're asking there. Change in momentum. By the change in momentum we can get the final. So from this equation, so now this is also. So here you see now. So delta p is equals to f into dx. F into dx is f into dt. F into dt. So this is nothing but what there, mv minus mu, no, mv minus mu into f into dx. We can add that. F into dt we can add that. F into dt. Okay. So if this velocity will be 0, means the body initially is at rest, means u is 0 there. Here we will get there v. So v is equals to f into dt. F into dt will be there. Then v is equals to f by m into dt will be there. F by m into dt. So that is a final velocity. So now what we have to do there? We have to substitute here. So then x equals to 3x, if you substitute there, we'll get that dt. Here dt. So dt what can write here now? Into t we can write. Okay. So now here v is equal. So this v is equal to, okay, so v is equals to is nothing but 3 into x divided by m into t is given there, into t there. Okay. So initial velocity. So this final velocity will be when the distance here. What is the distance we have to take there? x2 we should take there. So that is the final velocity, no? And time. Three into x. This is a 8 kg we can write here. So this is the equation we got now. V is equals to dt. So now this v is equals to f value is given there 3 into x divided by mass. Mass is how much there? It is given there 8. 8 into here time. 8 into time there. So speed will take here 1 second. T is equals to 1 second. If you take T is equals to 1 second in a 1 second. Per second we will be calculating. No? So then how much we get here? 3 into here x is the 10 we can add that divided by 8 into 1. So here we'll get there 4 and this is a 2 5s. Okay. Then we'll get here 15 by 4 meter per second. 15 by 4 means how much you get there here? 3 1s are 3, 4 1s are 4 3s are 12. Okay. So 4 3s are 12 will get here. 4 3s are 12. How much remains there? 12 means 3.7 meter per second will be there. So 3.7 means approximately we can take there 4 meter per second. So therefore, so V is it is approximately equal to 4 meter per second. That is the answer there. V is equals to 4 meter per second. So 12th one, a constant force F is applied on a stationary particle of mass m. The velocity attained by the particle in certain displacement will be proportional to mass. So here constant force is applied there. F is applied there on stationary particle of mass m. The velocity contained in the particle is in a certain displacement will be proportional to. Okay. So then F is directly proportional to. So from the fourth definition. So from the fourth definition, we will write like this now. F is equal to MNTA here. So from this, what can I write there? F is, if it is moving, acceleration there. Constant form means acceleration constant. Then it is F is directly proportional to mass now. So F will be directly proportional to mass there. When it is moving with the constant stationary particle of mass m applied on a constant force is applied there, the velocity attained by the particle is certain displacement will be proportional to velocity of the particle is directly proportional to. So F is a constant now. From we can write here F is equals to m into V by T we can write here. Then from this V is equals to what can I write here? V is equals to F into T divided by here m we can write there. So now F is constant there means the time duration also it will be constant. Then here the V is inversely proportional to mass of the body there. So this is a expression between the velocity and the mass. So this is a 12th one. This will be the 12th one. Velocity attained particle in certain displacement will be proportional to. So 12th one here we can see there. The constant force is applied on a stationary particle of mass m. Velocity attained by the particle in certain displacement will be there. So initially here in this case we can write like this. U is at 0, initial velocity. The mass body has the initial velocity will be 0 and mass is here m, and final velocity here. So velocity attained by the particle in certain duration. So velocity attained by the particle here. So final velocity and what is the relation here, and in certain distance there. Distance let us consider here s distance. So s is equal to s distance there. So from this equation we can write now square. Okay. So this will be 0. then v square is equal to what you get there, 2a into s will be there. Okay, so here a is nothing but what can we write there now? A is equals to, then distance will be constant, no? A is equals to, from this relation A is equals to 2 into, so f by m. Okay, so A is equals to f by m into f by m, we can write here, then this is the s there. Okay, now this force and distance is a constant there, and now from this we can write here v is equal to square root of 2 into f into s divided by, here m will be there. So from this we can write there v is inversely proportional to root of m. So this one we can write there by this formula. So here this is the case, whenever this acceleration is constant, we will get this relation. Okay, acceleration of the body is constant, or it is moving with the constant here v by t. So a is equals to v by t, no? Then if it is moving with velocity, uniform velocity, it is a is constant means v value may be changed, no? So but the change in velocity will be divided by the time, it will be constant. So in that case, constant acceleration will get this one, and here if it is moving certain displacement with constant force, then it is inversely proportional to the velocity of the body, final velocity of the body is inversely proportional to square root of mass 1 by root m. So this is the answer, this is the correct answer. So like that, there are the questions are there. Okay, you can solve that. Next, see here, bullet problem is there. Like this one problem I'll explain that. Then remaining problems you can do that. 14th one you see here. 14th one. A bullet of mass 0.3 kg, 0.03 each hit a plate at the rate of 200 bullets per second with velocity 30 meter per second. They are returned with the zero velocity. Then force acting on the Newton. Force acting on the plate is in newtons. Okay. Put in the problem. So mass of the body is given. Mass of the body is given, and then so rate of the bullets, 200 bullets per second there. Bullets per time, it is given there. This is the rate, no, number of bullets per time, that is given there. Is given there with velocity, and it is moving with velocity. So u is equals to 30 meter per second velocity. They are moving there and returned with zero velocity. The average force acting on the plate in newtons is, okay. So final velocity will become 0, and they are asking there what their average force, F is equal to, they are asking there F is equals to how much. So from this we can write here F is equal to m into a, no, m into a. Here only one particle is there means we can write here only mass m. There are a number of particles are there means whole mass can be added. If we have whole mass, there are n number of particles are there means n into m will come there. So into a is nothing but what here, v minus u by t will come, no, since a is equals to minus u by t. So a is equals to v minus u by t, no, from this formula we can write it now. So now here f is equals to n is how much, n by t. So here we can write there n by t, no. So like this we can write there n by t into, so here m into, here we can write there v minus u we can write it now. Here n by t is how much, 200 kg, and mass how much it is given there, 0.03 kg, and here final velocity will become 0, and this one is the 30 meter per second there. Okay, 200 if you multiply, you will get here how much. So final here calculation will give here 100 will be multiplied here means 3 will be remain there, 2 into 3 6, so we will get 6 into minus 30, 6 into minus 180 will get, no, this is minus 180 newtons will be active there. Minus indicates there that force is acting on the body to stop the motion of the body there. So that all the problems will be there. Here next problem. So velocity after, okay, here in the vector form it is given there. Okay, so one problem we will do on the vector form. 16th one will do there. So same, 15th one is same like this only. 16th problem. So 16th one you see here, mass of the body is given there 0.2 kg mass, which is at rest there. Okay, mass of the body is given there 0.2 kg and which is at rest there. Means rest is means initial velocity will be 0. Initial velocity will be 0 and is subjected to it is at rest, is subjected to a force. So force is applied there. That force equation is given here. Vector notation is given there 0.3 0.3 I cap 0.3 I cap minus 0.4 j cap is given there. Okay, there is a force vector is given now. Force vector is given. Then what they are asking there? Its velocity. What is its velocity vector after 6 seconds? So velocity vector they are asking there. Velocity vector is how much? So in a time t is equals to 6 seconds. After 6 seconds, what is the velocity vector? They are asking. So we know that from the force F is equals to F bar is equals to m into v m into a bar we can write now. Here a bar is nothing but what there. So m into v bar by t we can write now, because it is a acceleration is nothing but velocity by time there. So a bar is equals to v bar by t. So from this we can write here instead of a. Okay. So now everything is given over there. So mass is given and velocity vector they are asking there, time is given there and force is given there. So from this F bar is equals to we got here m into v bar by t is given there. T now v bar is equals to what happens here? V bar is equals to F bar into t divided by F bar into t divided by m we can write here. So what is the F bar is given there 0.3 I cap minus 0.4 j cap minus 0.4 j cap divided by mass how much is given there is 0.2 kg. Okay. So then time how much it is given there? Time it is 6 seconds. So therefore here v bar vector, what will get the v bar vector now? So 0.3 divided by 0.2 into 6 I cap minus 0.4 divided by 0.2 into 6 j cap. Okay, what is going to be cancelled there? This point and point will be cancelled here. It will be 3 will be remain now here. This point and point will be going to cancel here. It will be 3 remaining. 2 3s are 6. Then how much we will get here? V bar is equals to, this is a 9 I cap and here minus 12 j cap will get there. So this is a velocity vector. So the velocity vector is this one, 9 I cap minus 12 j cap. Option 1. So like that we have the problems in this synopsis 2. Then we'll go for synopsis remaining problems here in the practice sheet is some of the problems are there. We can also do in the practice sessions. The Newton's third law. About the Newton's third law in synopsis 4 it is explained there. Okay. We'll see there and Newton's third law, then we are going to see the free body diagram also. Synopsis. Synopsis third. Okay. So synopsis third is about the Newton's third law. See, first we will see their concept. In the Newton's third law, what we have discussed, their action and reaction will be equal, and action and the reaction will be pair of forces will be act on the two different objects, not on the same object. We have discussed there. And action and reaction forces are equal in magnitude, but in the direction they are in the opposite in the direction there. Okay. So here we'll see the some of the concept, and here we have seen there the law of conservation of linear momentum. The examples we have seen there now. The next then free body diagram. We have learned about the free body diagram. Free body diagram is nothing but the diagrammatical representation of a system or a body on which there are the multiple forces acting there, and the direction of the motion in which direction it is there. To represent that diagram is called the force acting. The diagram which represents the force acting on the body or a system is called the free body diagram there. Okay. So now see here, faced questions. First one is given there. Newton's third law is the law of conservation of energy. Okay, and law of conservation of momentum, law of conservation of kinetic energy, law of conservation of mass. Okay. So here we can say the law of conservation of linear momentum. Okay. Newton's third law will be explained. The momentum will be constant there. energy may be lost there. Okay, here the fuel will be there, no, mass will be decreases, fuel mass will be decreases. There the energy cannot be equal. Okay, then so it is momentum will be constant there. So we can write here the law of conservation of linear momentum. We can say that first option is law of conservation of linear momentum. The concept based questions there. Okay, and see the next second one. When a horse pulls a cart, the force that helps the horse to move forward is the force exerted by. When a horse pulls a cart, when a horse pulls a cart, the force that helps the horse to move forward is the force exerted by. Okay, is the force exerted by the ground on the horse. First one is given here, the cart on the horse there. So cart will be apply the force on the horse, means the wheels, whenever the wheels are rotated, that force is caused to rotate the means to move the horse forward there. Okay, so here the force that helps the horse to move forward is the force exerted by. It is tied to the cart, so cart will apply the force on the horse so that it will be move there. That force will be helped there. So we can write here first option. Second one is first option, we can write there. Okay. And a man is standing on the balance and his weight is measured. If he takes a step in the left side, then weight. So weight will be a man standing on the balance. Okay, and his weight is measured there. So by normal balance will be there, no? By using the balance we can find out that his weight is also measured there. If we take a steps, okay, by using a common balance, he has taken there. If he takes a step in the left side, then weight will be. So left side, if any side if it is lifted there, then it's his. It is balanced by its weight, has to be stand at the middle there. Okay. Then if we take left or right, then the weight will be, means which side is moved there, that side the weight will be increases, and from which he is moving away, from the side from which he is moving, the decrease. So then, so it will be increased. We can add there the second option. A book is lying on the table. What is the angle between the action of the book on the table and the reaction of the table on the book? Okay. So they are asking here, book is lying on the table there. What is the angle between the action of the book and the book on the table? Book. Okay, I will show in the diagram, then we will understand here. So this is the fourth one. Concept based questions, the fourth one. Fourth solution you see here. Suppose on a table, this is a table, consider there. Here a book is placed there. Let us consider this is a book. And the weight of the body will be act here downward direction. There is a mg. So a weight will be mg. Opposite to this, perpendicular to the surface, there is a normal reaction will be takes place. Okay. And what they are asking here, what is the angle between the action of the book on the table, action on the book on the table there. So this, what is the force applied by the book on the table? That is called action there. So that is action will be acting downward direction. That is what their weight. And opposite direction, what is the normal reaction? Means the table is acting on the book. That is a normal reaction there, acting upward there. What is the angle here? What is the angle between these two forces? They are asking there. So what is the angle here? They are in the straight line. So if they are in the straight line, then what is the angle we can say here? That is a 180 degrees. 180 degrees. Answer is 180 degrees. By the diagram we can say that. So now fifth one we'll see here. A cold soft drink is kept on the table on the balance. When a cap is open, then its weight is increases or decreases there. Okay. In the balance there, a cold soft drink is kept on the balance. When a cap is open there, if the cap is open there, then the weight is increases or decreases there. So if the cap is open, then soft drink will have it contains some gases. No, the gases will be come out from that. Then the weight is little bit weight will be decreases there. So here the fifth one we can write here. Weight of the body. So after placing here, after placing the left side, the weight will be increases. Then after opening the cap there, the gases will be released from there, then it will be decreases. Okay. So first increases, then decreases there. So option 3 we can have there. Fifth one is option 3. First increases and next decreases. So like that we have the problems. So seventh one is here, a gun fires n bullets per second there. Each of mass small with velocity v, the force exerted by the bullets on the gun is. Okay, force exerted by the bullet on the gun is. A gun fires n number of bullets. Okay, so here sixth one we see here, sixth solution. Sixth one. N number of bullets per second there. Okay, so time we can write here small n is equals to, then here mass of the each bullet we can write here mb. mb is given there here, there is a small m is given there. Then now with velocity they are moving, each bullet is moving with a speed here, velocity of the bullet is here, it is given there v. Okay, so what they are asking here, then the force exerted by the bullet on the gun, force exerted by the bullet on the gun there. Okay, so the force formula F is equal to what can I write there here, mass into acceleration. Okay, so mass of the gun, how much it is given there, so mass of the bullet, number of bullets are given here. So here there are many number of bullets are there here, this mb we can write there, mb, how many number of bullets it is given there, n by t, n by t. Okay, so n number of bullets, and here v is nothing but what there, acceleration nothing but v by t we can write, all t we have written here. So a is equals to v by t we can write there, a is equals to v by t there. Okay, then f is equals to we can write here n into v we can write there, n into v. So now here v is nothing but what happens here, v is equals to f by n will get there, f by n. So f by n will get, so v is equals to f by n. So what they are asking actually here, so they are asking the force exerted. So force exerted is nothing but n into v we can add there, n into v here. So this is number of bullets here, mass of the gun is there, here m will be present there. So here then this one is m will be there. So from this they are asking only the force, then we will get here n into f is equals to n into m into v will be there. So this is a force exerted by the body. So next problems are given there, free body diagram there. Okay, a book lying on a horizontal table, then free body diagram of the book. So already here I written now the same. So this is for this we can write here, seventh one we can write, this is a seventh solution. See here free body diagram there. So free body diagram, this is the normal diagram we have drawn there now. So a body lying on the plane. So now free body diagram, we write here FBD. So FBD will write here, there is a point size mass will write here, the mg weight will back downward direction, and this is a 180 degrees angle between the two forces. So now here what can write the equation there, W is equals to, so n is equals to m into g, because there is no acceleration, simply it is laid on the table. Okay, n is equals to mg will be the answer there. So free body diagram, how it would be there, so normal reaction, so even it can be here the block also can maybe represent, normal reaction will be upward and the weight will be downward. So like that we have the problems there, and here we'll see there some of the block. So these are the free body diagrams, so there are the problems are given there by strings are connected with the masses. So now here you see that this is synopsis, and here in the synopsis here exercise problems are there, that is based on the free body diagram we are going to see here. See in the exercise problem page number 152, the force on the racket existing, this is based on that formula only there, and now here it is given there, this one third one is given like this. So second one is also same like this only. Then here you see there problem is given like this. Third question you write here. So mass of the block here. There here the tension will be there. Tension T1 and T2 will be there. Here it is given there T1 and mass is given. Mass is the M1, M2, M3 is given. So M1 horizontal force is applied. Okay. So an horizontal force is applied there. Then they are asking their acceleration of the system. So here according to the if the force is moving acceleration of A. Okay. So generally from the second law, what can we write there? Force is nothing but product mass, total mass. We can write here capital M to A we can write there. Now here capital M is nothing but from that mass there capital M is equals to sum of the three masses here. So M1 plus M2 plus M3. M3 we can write here. So that here F is equals to what can we write there now? So M1 plus M2 plus M3. M3 here we can write there and here A. So now A is equals to here F divided by M1 plus M2 plus M3. M3 we can write. So this is a acceleration. Simple only, no? Right. And the same problem. In the fourth one they are asking there what is the mass of this first one? Mass of the tension T here. What is this tension? In the fourth problem they are asking what is the value of T. T1 what can we write here now? To find out the T, here we will write their free body diagram. See, so mass M1 mass is there here and the tension only the one force is acting there and it is moving with acceleration in the right side direction there. So now from this we will get the equation as here M1 into A. No? What is the A value we got here? F divided by that value, no? Here we can substitute there, we will get the answer there. Otherwise, directly this answer only is given there. Therefore, the tension is it is here M1 into A even. So it also can be represented as here M1. Okay, M1 divided by M1 plus M2 plus M3. M3 divided by into F. This is the also we can add there. Okay, suppose only acceleration is given means we can find out by using this. There is no acceleration is given there, force and this mass are given, then we can find out the tension here. So in the same way, here T2 also we can find out, this T2 also we can find out there. Okay, by drawing, by writing the here free body diagram for the second block, already we got there T1, then T2 we can find out by using the free body diagram there. Okay, like this, all the questions are there, so we can solve them like that. And next example is given here, two blocks. Then different blocks are connected not by the strings there, simply they are connected, physically contact the bodies or contact blocks. Like the problem, how to solve that. Okay, we will see there here. Like here, 13th problem is given. 13th problem. Yes. So 13th problem, what they have given there? 16 kg mass is given here. 16 kg mass. And here 8 kg mass, and then here next 4 kg mass. 4 kg mass, and then so this is a 4 kg mass, and this will be 8 kg mass, and this will be the 16 kg mass. Now where the force is applied there, here like this, this is a kg, here 150. So F is act here 140 newtons. The force is acting there. If the 140 newtons is applied there, and they are asking there the force on the 16th. The force on the 16th they are asking there. See here. So this will apply. 4th block will apply the force on the 8th block, and 8th block will apply the force on the this one. So like F8 we can add there. F8, and this one we can add here F4. So means the 4th block will apply the force on the 8. This one and this one. Now here, what are the forces are acting here? What are the forces are acting there? That we should find out. Here on the 16th block, F8 is acting and the 40 newtons. So 40 newton force is acting there. Both are in the same direction. No. So Then what is this F8? How much force acting on the 16 kg block? So means only F8 is acting on the 60 kg. So this 140 is acting on the force 4 kg of mass of the body now. So then F8 we should find out there. So what can we write this? All the system will be moved towards the left side. Then here we can write their capital F plus F8 is equals to so mass of the body is almost there 16. So 16 into acceleration. So how we have to written there? We could draw the free body diagram. So already here F is acting there, and here next so F8 is also acting there, and this is a block mass 60 kg mass and moving with acceleration A. Here. So how to find out here acceleration? So if you find out the acceleration, we'll get to know then. Okay, acceleration, how to find out there? Here total force is acting on the block. So from M is equals to M into, so F is equal to M into A. So 3 masses are there, no? Here 3 masses means, so here 16 plus 8 plus 4 will get into A, and this is what there 140. Okay, then how much? A is equals to how much will get there now? 140 divided by 28 now. This will be the 28. So 28 there. So how much we get there? So this is a 14 2s and 14 10s and 2 1s and here 5s. So we'll get here is a 5 meter per second square. Acceleration we got here now. So substitute your acceleration, then all the values you substitute, you will get the answer there. This is 140 plus here F8 we should find out here. Now this one. Force F8 no. So this is 60 into here how much there 5. So here we'll get there 140 minus how much we get this one here. So here 8 Newton acting on this force. Okay, here instead of F8 we can add there this one no 4 plus 8 16 we can add there 12 no 12 into 5. On the 8th block there is this force is acting on here, that is 4 into 8, and due to these two blocks mass of the 8 and the 4 12 mass is acting on the force on the 60 kg there. Okay, so then here we can add there resultant force. This is a 140, and this one we can add here mass of the body 16 kg no 16 kg mass. F8. After finding the acceleration there, we can find out there. So 140 plus F8 is equals to 140 plus F8 is equals to here. This one 50 plus 30, 80 will get there. 80 newtons will get no 80 newtons. 80 newtons. So this here directly we can write here F 140 newtons is applying there 50 newtons force on the 16 kg. So therefore we no need to take this value here 140 no need to take. So simply we'll get here F8 is equals to. So here F8 here the force acting by the 8 kg mass on the 16 kg mass there. So they're asking the mass acting on the body here. So 16. Okay, 16 mass of the body 16 and acceleration of these blocks is 8. So we can add there. Now the force acting on this block we can add here F8, that is therefore we can add here F8 is equals to. So F8 is equals to 80 newtons we can add there. That is the answer. J means 13th one. So like this problems will be there. Okay, now next one we will see there here. Next synopsis. So in the synopsis of fourth, it is explained about the pseudo force, inertial frame and non-inertial frame. Already we have discussed there. The lift is moving upward and downwards. So with what is the acceleration? Effective acceleration is what there. About that only it is mentioned there. So this one, okay, now we'll do the numericals there. See, concept based questions is given there. A block of mass m is placed on a smooth wedge of inclination near theta. Of inclination, theta is given. So next one, synopsis 4. Now synopsis 4, it is explained about the inertial frame and non-inertial frames there. Already we have discussed, then lift is moving up, what is the effective acceleration will be there, and lift is moving down, what is the acceleration we have seen there. The net acceleration we have seen there now. Now based on that, there are the problems are there, we will see here now. A block of mass m placed in a smooth wedge of inclination theta, the whole system is accelerated horizontally so that the block does not slip on the wedge. The force exerted by the wedge on the block has a magnitude of, okay. So it is given like this there. So first solution you see here. So wedge is nothing but like this. An inclined plane is given there. This is a wedge there, and it is moving. On this there is a block is placed there. On this there is a block is placed like this, and the inclination of this it is the theta. Inclination of that, it is the theta there. Okay. So now the weight of this block will be act always it is downward direction. It is a mg. Okay. If this is a mg, then we can divide this one as this is theta, means this also will be theta there. So it can be written as here mg cos theta, and here we can write here this is a mg sin theta, mg sin theta now. Okay. So the normal reaction, how it will back there? This will be the normal reaction. No? This is a normal reaction. It will back there. So now normal reaction has to be theta. Okay. If this is theta, then what it will be this one? This will be the 90 minus theta. Okay, this is a 90 minus theta there. So it is a 90 will be there, and this one will be theta. Okay, this also will be theta. No? Now this force cos theta here, and now horizontally like this. This is a horizontal force. This will we can write here n sin theta. We can write there n sin theta. Okay, n sin theta. So now here they given there mass of the block, mass of a block of mass small m. This mass of this block is here small m, and the wedge has a mass placed on the wedge, smooth wedge of inclination theta. Whole system is accelerated. The force exerted by the wedge on the block has a force exerted by the wedge. See here, now what is that force exerted by the wedge? It is, we can add normal reaction on this one. Normal reaction we can add there. The block is, the block applying the force here, mg cos theta, and the wedge is applying the force here n. So from that here we can add directly, n is equals to mg cos theta, we can add that, mg cos theta. This is the normal reaction, is nothing but the wedge is applying the force on the block there, mg cos theta, we can add there. The force exerted by the wedge on the block has the magnitude of mg cos theta. Normal reaction is nothing but the block, this wedge applying. Now here horizontal force, the block is moving. Then horizontal force we can add here n is equals to n sin theta. N sin theta is equals to, we can add here m into a, we can add there m into a. Okay, now from that so we can add here normal reaction n is equals to ma by sin theta, we can add that here. N is equals to this one normal reaction we can write there. Okay, that is the so mg N is equals to mg cos theta will be the answer. Now second one is either a bob of mass m is a bob of mass. Bob is nothing but a metallic spherical body is called the bob. So that is given here. The system is accelerated horizontally. The system, whole system is moving accelerated here. It is moving, like it is moving acceleration here. Okay. So in the first one, you see that here it is moving with acceleration g. The block does not slip. This block does not slip means the here this block is moving with horizontally. If it is moving horizontally, then N is equals to MA by sin theta will get there. MA by sin theta. Okay. So then now here we can add there this N cos theta. So N cos theta is equals to we can add here mg we can add there, and N sin theta. So N sin theta is equals to this one we have written, no? N sin theta is equals to m into a we can add there, m into a force mg. Okay, now here tan theta is equals to we can add here that is tan theta is equals to m will be cancelled, a by g will be there, a by g. Then a is equals to we can add here g tan theta, we can add here g tan theta. A is equals to g tan theta. So acceleration of the block we can add here g tan theta, we can add there g tan theta. Okay. So now if you write here this one N is equals to normal reaction, no, they are asking the normal reaction there. So then N is equals to N will be the N is equals to what is the equation we got there? M into A is nothing but what here? G into tan theta we got here. Instead of this here we can add there G tan theta, we can add G tan theta divided by sin theta will be there here. So then now here so N is equals to we can write here mg sin theta by here this is a sin theta into cos theta, we can add here cos theta. Okay, now this sin theta will be cancelled. Therefore normal reaction we can add here mg by cos theta we can add there mg by cos theta. Okay. So whenever the body is this here N is equals to mg cos theta we got there, this is at rest there. So it is at rest. If the body is not moving. Once the body has started moving there, this means this wedge is moving. Wedge is moving like this. Then so the normal reaction will be applied with does not slip. This block is not slipping from the from this wedge. Then the normal reaction there it has to be active. Normal reaction it is nothing but what there? The wedge acting a force on the block there. That will get there mg cos theta. So for the first one we'll get the answer as mg cos theta, mg by cos theta, mg divided by cos theta. Okay. So in the same like this only we have the next problem. Next one, second one you see here. Second solution. A bob of mass m is suspended from the ceiling of a train moving with an acceleration a as shown in the figure. Find the angle theta in equilibrium position. Angle theta in equilibrium position there. Okay. So here a train, a body is moving with certain acceleration here. It is moving with and at the ceiling there is a pendulum has connected, tied, okay, and if it is moving like this pendulum will be, it will be move, oscillate like this with certain angle theta here, okay. And now here at equilibrium, they are saying at equilibrium here, the body is moving with this acceleration there, the weight of this will be back downward direction here mg, okay, and if this is theta, and if you write like this, so this will become here mg, this also will be theta, no? So mg cos theta we can write here, and this is perpendicularly, this one we can write here. Okay, this one we can write here mg sin theta. Okay, this one we can write here mg sin theta, we can write now mg sin theta. If this is theta, then this also will be theta, we'll get like this. Now you can see here weight, no, and this weight, if this is theta, here we can write this also will be theta, no, this also will be theta. Then in the thread there is a tension will be there, this L or tension will be there, no, in the thread there is a tension will be there, tensile force. So we can write here T cos theta we can write, and this side horizontally it is like this, T sin theta we can write as T sin theta, T sin theta, okay. So now here, so T cos theta, horizontal, vertical force error, it is T cos theta is equals to mg, we can write here mg, and now T sin theta. So T sin theta is nothing but what can I write here? The block has a mass m and is moving there, okay. So m into a we can write now, m into a we can write there. So now this is equation 1 and equation 2, if you write there equation 1, divide equation 1 and equation 2. So if you divide equation 1 divided by equation 2, we will get there T sin theta. So T sin theta divided by T cos theta, that is equals to, we'll get here ma divided by mg will be there. Okay, this and this will be cancelled here, and T also will be cancelled. So this we can write here tan theta. So tan theta is equals to, we can write here a by